Have you ever stopped to wonder if the universe you live in might not be exactly what it seems? What if I told you that science, not philosophy, not religion, but quantum physics itself, is beginning to prove that reality is a carefully orchestrated illusion? That's exactly what the 2025 Nobel Prize in Physics just revealed. For the first time, experiments confirm that quantum effects, once confined to the invisible world of atoms, can appear on a macroscopic scale. In other words, what we believe to be solid, predictable, and separate isn't. Reality is a field vibrating in response to the consciousness that observes it. And once you understand that, everything changes. But hold on. I know this idea challenges everything you learned in school. For centuries, science separated the small from the large, the quantum from the human. Yet now, with these award-winning experiments, that boundary has collapsed. Entire superconductors are behaving like atoms, tunneling through barriers, proving that coherence can exist in systems made of billions of particles. This isn't just cutting-edge technology. It's proof that the foundation of the universe itself is quantum. And if everything is quantum, then what is real? What is self? Where does matter end and consciousness begin? What fascinates me most is that this discovery is both scientific and spiritual. Because by confirming that reality depends on environmental conditions, it echoes an ancient principle. What you focus on expands. Physics is now saying, through equations and experiments, what spirituality has whispered all along. The observer is part of the phenomenon. The universe isn't a dead thing waiting to be studied. It's a mirror, a responsive field, a living organism that reacts to your gaze. That's why when you change how you observe, you also change the outcome. So before we go any further, answer me this. What if the solidity of your life, your problems, your fears, your limits, were also a quantum illusion, held together only by the frequency of your attention? And what if this Nobel Prize revealed not just a scientific breakthrough, but a key of perception, one that could free you from the rigidity of reality itself? Stay with me until the end, because what comes next will show you that to understand the universe is, in truth, to understand yourself, and that reality can be shaped through. I want to show you, plain and simple, why quantum physics didn't stay locked inside a test tube. It broke out of the microscopic world and began moving entire pieces on the board. When I say macroscopic coherence, I'm talking about countless electrons moving in sync as one, a phenomenon science has already measured in real superconducting circuits. Think about it. When a barrier seems impossible to cross, quantum tunneling lets you pass through, as if you'd found a hidden doorway. This changes how we see the future of technology, and at the same time touches the spirituality of anyone looking for meaning beyond the obvious. I'm not asking for blind faith. I'm inviting you to notice how solid data point to a more flexible universe. And yes, that opens questions we'll connect very soon. When I compare these systems to a perfectly tuned guitar, it's because it makes everything easier to picture. It's not random noise, it's a clean chord vibrating together. Here, quantum physics becomes practical, not poetic. Electrical resistance disappears, Cooper pairs form, and the phase, that inner rhythm, coordinates everything. When I look at science, I see a handbook for the future. More sensitive sensors, more stable measurements, and computing that runs on phase, not just on zeros and ones. Behind all of this, there's discipline, lowering temperature, shielding noise, and designing junctions like crafting a piece of art. And if spirituality interests you, notice the parallel. A coherent environment supports presence, focus, and less friction. I'll guide you through this step by step. Want a real-world example I'd use right now? Medical devices using squids can detect tiny magnetic fields in the brain, thanks to this same macroscopic coherence. Quantum physics improving diagnosis here and now. Another example, Superconducting qubits act like phase particles moving through an energy landscape. When I reduce interference, I unlock stable logic gates. How do you apply this logic in daily life? I'd suggest creating low-temperature behaviors. Less multitasking, more focused rituals, fixed times for deep work. For study, I recommend Introduction to Superconductivity by Tinkham, and Quantum Computation, and Quantum Information by Nielsen and Chuang. This way, you turn curiosity into method, and method into the future. I also want to dismantle a myth you might carry. There isn't a strict wall separating the quantum micro from the classical macro. There's context. When I prepare the right environment, nature shows coherence on larger scales, and that changes the whole conversation about reality. The science still holds, but what shows up depends on how we set up the experiment. Or, put simply, how we set the stage. That's why labs invest heavily in cryogenics, shielding, and circuit design. Without a stage, there's no performance. Now, if you're curious to see how that stage was built over time, from the first clues to the experiments that confirmed it all, I'll take you down that historical path next. That's when all the pieces finally start to fit together. When I look at the history of quantum physics, I see an invisible thread that stitches together centuries of curiosity. In the early 20th century, scientists tried to make sense of the mysterious behavior of electrons, light, and the tiny particles that make up everything. That's when the world began to realize that reality wasn't as solid as it seemed. I like to think of that moment as the first crack in the wall of certainty, the point when science looked into the invisible and discovered that the universe was more like a song than a machine. But it's fascinating, isn't it? For decades, people believed that this music only played on atomic scales, as if the larger world were deaf to it. But the future loves to challenge our certainties. Decades later, discoveries in superconductivity began showing that this quantum orchestra could also perform on a bigger stage. When I read about Kamerlingh Onnes's 1911 experiment, the one that revealed materials where electrical resistance simply vanished, I realized how much nature enjoys surprising us. And even more astonishing, by the mid-20th century, scientists learned that electrons could pair up, called Cooper pairs, and move as if they were a single body. Quantum physics, once thought distant from everyday life, was now flowing through the world of real electric currents and circuits. Then came something almost poetic, the Josephson effect. Picture two worlds, two superconductors, separated by a thin insulating barrier. What would you expect? Nothing to pass through, right? But science showed the opposite. Pairs of electrons crossed that barrier, as if the impossible were only a matter of perspective. This is quantum tunneling on a macroscopic scale. And what's even more incredible is that this effect produces current without voltage, pure motion without force. Whenever I think about that, I can't help but draw a spiritual analogy. How many times in life does something seem impossible until the right energy finds a way through? These experiments became like lighthouses, illuminating the border between the microscopic and the macroscopic, between what we call science and what still feels like mystery. They proved that quantum coherence, this invisible synchrony, can involve trillions of particles acting as one. That changes everything. The way we understand matter, consciousness, and even the boundaries of what's possible. When the 2025 Nobel Prize recognized this leap, it didn't just honor a theory. It celebrated the confirmation that the universe is more unified, more vibrant, and less predictable than we ever imagined. Now, if you want to understand how this coherence truly works, and what happens inside these experiments, stay with me, because the next part dives right into it. Now that the historical foundation is clear, I want to guide you inside the very structure of quantum physics, where mathematics reveals what the eyes can't see. Imagine a particle moving forward until it hits an energy wall. According to classical logic, it should stop there, like a car crashing into a wall. But science says there's a chance, small yet real, that it can pass through as if the wall were made of mist. That's quantum tunneling. Schrödinger's equation shows that a particle's probability wave doesn't die completely inside the barrier. It just weakens. And if the wall is thin enough, part of that wave survives on the other side. This subtle mathematical detail is what makes possible the technologies you use every day without realizing it. But what happens when this phenomenon stops being about a single electron and starts involving billions of them? That's where the magic of superconductivity begins. When a material is cooled close to absolute zero, electrons join in pairs, those famous Cooper pairs, and flow without resistance, like a river without stones. That's where quantum physics becomes alive and collective. I like to think of it as a spiritual metaphor. When two consciousnesses fall into resonance, life's friction fades and flow becomes effortless. This harmony among particles isn't just scientific poetry. It's the foundation of what we now call macroscopic quantum states. To understand the next step, imagine the Josephson junction as a bridge between two superconducting worlds, separated by an ultra-thin barrier. Inside it, a sea of electrons moves in perfect synchrony, guided not by mechanical force but by quantum phase difference, a subtle variable, like the rhythm of an unseen melody. The current flows even with no voltage applied, and when we introduce a small voltage, it begins to oscillate at extremely high frequencies. That's how tunneling becomes visible on a large scale. This isn't science fiction, it's real quantum engineering. And honestly, understanding this behavior feels like learning to speak the language of the universe. When the system is pushed out of balance, the so-called phase particle can escape an energy well not through heating, but through collective tunneling, something science calls macroscopic quantum tunneling. This is where the impossible takes physical form. An entire circuit crosses an energy barrier, as if it were a single conscious being. These experiments revealed the exact point where the transition between thermal and quantum behavior happens. The moment when nature itself seems to whisper, "Now it's my turn." And it's at this frontier that the future of quantum computing rises, because controlling that boundary is like holding the thread of reality before it unravels. In the next step, I'll show you what all this means, not only for science, but for how we understand reality itself. Now that you understand how quantum tunneling actually works, I want to show you why it matters, and how this discovery completely changes the way we see the world. The first thing that stands out is the conceptual impact. The old boundary between the quantum and classical world simply collapses. There's no clear line where the quantum ends and the normal begins. Everything depends on environmental conditions. When we isolate a system and reduce noise to the bare minimum, the universe reveals its true nature. Everything vibrates in coherence. To me, that's almost a spiritual lesson embedded in science because it shows that chaos isn't the rule. It's just the absence of harmony. And what's fascinating is that this harmony can be cultivated, both in laboratories and in the human mind. But maintaining coherence is no simple task. The slightest interaction with the environment, a vibration, a bit of noise, an atom out of place, and everything unravels in the blink of an eye. This process is called decoherence, and it explains why we don't see coins in superposition or people walking through walls. Deep down, the universe is quantum, but everyday life is too noisy for us to notice. It's like trying to hear a pure tone in the middle of a storm. That's why the experiments that won the 2025 Nobel Prize required extreme isolation and temperatures near absolute zero. And here's the curious part. The same principle applies to our inner energy. Without silence, without focus, inner coherence fades away. From this pursuit of coherence comes one of the greatest promises of the future. quantum computing. Those superconducting circuits with their Josephson junctions form the heart of qubits, the basic blocks of quantum processing. Each qubit behaves like a particle of phase that can exist in two states at once, and the key lies in preserving that duality as long as possible. When scientists talk about long coherence time, they're literally trying to hold on to the universe's breath before it vanishes. And the beauty of it is that this very same principle, preserving the quantum state, will enable computers millions of times more powerful than the ones we use today. Now think about this. If science is learning to control the very structure of reality, what does that say about us? If everything is quantum, and coherence can be sustained under the right conditions, could consciousness work the same way? A field collapsing possibilities depending on focus and energy? That's why the progress of quantum physics isn't just technological, it's philosophical. It pushes us to rethink what we call real, and to accept that reality might be shaped, not just observed. In the next step, I want you to see how far this idea can go, from the meaning of macroscopic to the deepest questions about where the quantum meets the human. When I say macroscopic, you might picture something the size of a cup or a person, but in quantum physics the term has a different flavor. Here, macro means that billions of particles, electrons, atoms, photons, behave as one, vibrating in perfect coherence. Imagine a crowd walking silently in the same direction, without bumping into each other. That's what happens in a superconducting circuit. Every electron, every Cooper pair, moves in the same rhythm, as if following a shared intelligence. And this state is so fragile, so sensitive, that any external interference, a sound, a vibration, a bit of heat, can break the spell. That's why scientists become almost like monks of science, isolating their experiments from the world, as if protecting a flame from the wind. Temperature plays a decisive role here. When a system is hot, thermal agitation pushes particles into chaos, making them jump over energy barriers like moths chasing light. That's classical behavior. But when the temperature drops to almost inhuman levels, something extraordinary happens. The jump stops depending on heat and starts happening through quantum tunneling. The escape rate becomes constant, unaffected by temperature. And that's how scientists identify the quantum domain. To me, that transition point is a powerful metaphor. Only when internal noise quiets down can coherence emerge. It's a reminder that balance in both science and life is born from the calm of control, not the heat of haste. And by mastering that control, the technologies of the future are born. Today's quantum engineers design circuits based on Josephson junctions with nanometer precision, tuning frequencies, couplings, and coherence times as if composing a cosmic symphony. Those same structures that once proved macroscopic tunneling are now the building blocks of the qubits used by companies like IBM and Google. It's fascinating to realize that research once seen as pure philosophy of quantum physics is now the beating heart of a technological revolution. It's the past and the future speaking inside a single chip, and all of it depends on one thing: maintaining silence within chaos. But perhaps the most fascinating questions are the ones that remain. How far can we go? Could an object visible to the naked eye one day display quantum coherence? And if that happens, where does the line lie between the quantum and the classical, between matter and consciousness? Some say the collapse of the wave function is simply the limit of our perception. Others believe it's the very act of observing that defines what's real. Either way, the 2025 Nobel sparked a fire that goes far beyond technology. It touches the mystery of existing in a universe where everything vibrates, everything interacts, and nothing is ever truly separate. And it's there, in that entanglement, that the next step of our journey begins. When I look at the 2025 prize, I see more than a golden medal. I see confirmation that quantum physics is the invisible thread stitching everything together, from the atom to the thought. And when scientists say everything is quantum, they're not exaggerating. What once sounded abstract is now something tangible, tested in labs and built into real devices. It's as if science finally admitted what spirituality has whispered for millennia. Everything is connected, and separation is just an illusion of the senses. When an entire circuit behaves as a single quantum state, there's no inside or outside, only a field of possibilities moving in perfect harmony. I like to think of the universe as this cosmic lab, where each consciousness is a particle learning to vibrate. But this understanding also comes with a challenge. Realizing that decoherence, the noise that breaks harmony, is the same phenomenon we experience when we disconnect from ourselves. In a lab, a little heat is enough to destroy coherence. In life, a single unfocused thought can do the same. Science and spirituality meet here. Both teach that everything depends on the environment. A physicist needs thermal isolation. A human being needs inner stillness. In both cases, it's noise that hides the truth. So learning about quantum physics is, in a way, learning to keep your own field clean, to stay in resonance with what you want to create. And if you think this is just philosophy, look around you. Every quantum computer, every ultra-sensitive sensor, every atomic clock, all of them are direct expressions of this understanding. They exist because someone dared to believe the boundary between the micro and the macro could be crossed. It's the same kind of courage that drives the human spirit to change its own reality. Because in the end, what science calls quantum tunneling is the perfect metaphor for life itself, breaking through barriers that once seemed impossible. When that happens, the impossible becomes just another frequency learning to vibrate in tune. Now, perhaps the most intriguing part is what comes next. If coherence can be preserved in circuits, could it also be cultivated in states of consciousness? And what if the collapse of the wave function, that instant when reality takes shape, happens inside us, with every choice, every thought, every emotion? That's the bridge between science and spirituality that this Nobel reignites. Because deep down, understanding the quantum universe means understanding yourself, realizing that reality is flexible, that the future already exists in potential, and that the observer holds power over what is observed. And that's exactly where the next chapter of this journey begins. Looking at it now, it's clear that quantum physics isn't just a branch of science. It's a new lens through which we see everything. It builds a bridge between logic and mystery, showing that even the most solid certainties can dissolve when viewed from a different angle. The experiments that once blurred the line between the micro and the macro are now the foundation of technologies shaping our future. Quantum computers, precision sensors, atomic clocks, they all emerge from this awareness that the universe is, at its core, a vast field of possibilities constantly collapsing into form. The 2025 Nobel Prize isn't just about tunneling in circuits. It's about confirming that reality itself is malleable, and that changes everything. Hidden between the lines, there's an invitation to take part consciously in this cosmic dance. At its heart, learning this science is like learning a new language, the language of the universe. The equations that describe tunneling, coherence, and superposition aren't just abstractions. They're mathematical expressions of what spirituality has always felt. When a quantum system remains stable, it's practicing a kind of meditation, shielding itself from external noise and maintaining focus on its own frequency. And if you look at your own life, the same principle applies. The clearer your focus, the more predictable the outcome. It's the collapse of possibilities into lived experience, quantum physics teaching without words, how to create reality. But here comes a deeper question. How far can the quantum reach? Could a visible macroscopic system stay coherent? proving that the large-scale world follows the same subtle laws as the atom. That's the question driving new experiments, and it echoes through the philosophy of consciousness. Because if everything is quantum, then the observer and the observed are two faces of the same mirror. Science is moving closer to spirituality without realizing it, and spirituality grows stronger when grounded in science. What were once separate domains now intertwine, forming a new vision of the future, one where the human mind and the structure of the universe follow the same code. And while scientists keep testing the limits of decoherence, we test the limits of our own perception, because maybe classical reality, the one that feels so solid, is just a special case of a greater truth, that everything vibrates, everything is energy, everything is consciousness in motion. The quantum universe isn't out there, it pulses within us, responding to our focus, our thoughts, our intentions. That's what makes this discovery so powerful. It doesn't just explain how the world works, it shows that the world responds. In the next step, I want to guide you through the summary of this journey and show how to apply this knowledge in a practical, transformative way. If I could sum up the whole journey of quantum physics so far, I'd say it teaches a lesson that goes beyond science. Reality isn't fixed, it's dynamic, and it responds to the coherence of the observer. And believe me, that applies to an atom just as much as it does to your life. Once you understand that decoherence destroys order, you start to see the importance of maintaining focus, whether in the lab or in your dreams. Science has shown that when a system is well isolated, it preserves its energy and displays extraordinary behavior. Now imagine applying that principle to yourself. Fewer distractions, less interference, more silence. Because just like a quantum circuit, your mind needs ideal conditions to create. The beauty of this discovery is that it unites past, present, and future in a single point. In the past, we thought the quantum world belonged only to atoms. In the present, we know it governs entire circuits and machines. And in the future, maybe quantum physics will reveal that consciousness is the missing link, the field connecting observer and phenomenon. When you grasp that, the world becomes a lab of possibilities. Every thought, every emotion, every choice is a variable in this cosmic experiment. At that moment, the future stops being something that comes and becomes something that responds. The scientists of today, manipulating Josephson junctions and measuring coherence times, are doing more than engineering. They're expanding the limits of what's possible. They're learning to communicate with the universe in its native language, the language of frequencies. And if you listen closely, you'll realize spirituality has been speaking that language all along. What we call prayer, intention, or faith is, at its essence, a tuning of frequency, the moment when the human mind and the quantum field resonate together. This bridge between science and spirituality isn't accidental. It's where reason bows to mystery, and mystery validates reason. So, when someone tells you it's just physics, remember, it's quantum physics that reminds us everything is interconnected. Nothing stands alone. Even the observer is part of the experiment. The 2025 Nobel didn't just honor scientists. It honored a worldview where matter and consciousness are two sides of the same coin. With every new experiment, we move closer to the answer we've always sought. What is reality? And the beauty lies in the possibility that maybe reality isn't a thing, but a constant dialogue between what we see and what we believe. And that dialogue continues, as knowledge turns into living wisdom. If you've made it this far, you've probably realized that learning about quantum physics is more than just understanding particles. It's about understanding yourself. Every concept, every discovery is a mirror reflecting how we think, feel, and interact with the world. When you understand that decoherence destroys harmony, you start to see the importance of protecting your own inner field. Just like a circuit needs thermal silence to function, You also need mental silence to create. And when science says everything is energy, it's saying that everything vibrates in response to attention. To focus is to collapse possibility. And if reality responds to coherence, then the greatest laboratory that exists is your own consciousness. The difference between the classical and the quantum is, at its core, a matter of focus. In the classical world, noise dominates. In the quantum world, order emerges. This applies both to technology and to life. The classical thrives on distraction, the quantum on presence. Once you grasp that, you begin to see that science isn't outside of you. It's a living metaphor for your mind. Want an example? In quantum computing, the secret isn't power, but control. In life, it's the same. It's not speed that moves you forward, but the coherence between what you think, feel, and do. That's true human superconductivity, acting without resistance, flowing with purpose, and letting energy move freely. That's why I like to think of learning about the quantum universe as learning to live with greater awareness. Every scientific discovery hides a spiritual lesson beneath it. When science shows that everything is connected, it's echoing what ancient masters always taught. Nothing is separate. When it reveals that observation changes the outcome, it reminds us that perception shapes reality. And when the 2025 Nobel Prize proves that the macro world is also quantum, it's telling us that the invisible shapes the visible, that the reality you live in isn't a fixed destiny, but a vibrational choice made in every moment of attention. So, if you want to learn quantum physics, start with the basics. Learn to observe. Observe without hurry, without judgment, with full presence. It may sound simple, but that's the foundation of coherence. And when you can sustain that presence, you'll notice that the universe responds, not as theory, but as direct experience. That's why understanding the quantum field is so powerful. It doesn't ask for blind faith. It asks for awareness. And maybe that's what this year's Nobel Prize came to remind us of. That the true future of science doesn't lie in the machines, but in the mind that builds them. And that's where the next stage begins, where knowledge turns into practice, and theory becomes real transformation. If everything you've heard so far sparked that feeling that the world is much bigger than it seems, then it's time to put this knowledge into practice. Quantum physics isn't just in books. It's in the way you live, observe, and respond. Every thought is a measurement, every emotion is a frequency, and every choice collapses a possibility. So here's a direct question. What have you been feeding with your attention? The fear of what might go wrong or the trust in what's already working in your favor? Because the field responds, and it does so with scientific precision. I want you to look at your life right now and notice where decoherence has taken over. Where there's noise, distraction, or disconnection. Then ask yourself, what would happen if you reduced that noise even a little? What would change if you isolated your inner system, just like scientists do with their circuits? Maybe the impossible would start behaving like the possible. Maybe the harmony that once felt distant would begin to form naturally. That's the real application of knowledge, turning theory into a state of being. And if the entire universe is a quantum laboratory, then you are the most fascinating experiment there is. Nothing is out of your reach, only out of your coherence. So the question that remains is simple yet powerful. What will you choose to observe from now on? Will you keep believing in the rigidity of reality, or start testing the plasticity of existence? Remember, reality isn't a sentence, it's a conversation. And the clearer your vibration, the better the universe understands what you're trying to say. If this message stirred something in you, a question, a spark of curiosity, a new kind of light, write in the comments what made you think the most. Share this discovery with someone who also feels there's more beyond the obvious. And most importantly, subscribe and turn on notifications because this journey doesn't stop here. The next step will show you that the power to transform reality isn't found in equations. It's found in you. And the universe,